Hello, thank you for joining me today. Today we're going to finally talk about the final presentation because we had the midterm presentation last time. So the video right before this was the midterm presentation. And this is for my master's degree in radiation health physics or health physics in general. I usually just tell people it's nuclear physics because if I say health physics, people don't know what that is. It is think of like nuclear engineering, but more in the safety and the public awareness and healthcare, more in that kind of sense than just like nuclear engineering, where you're making constructing new type of technology for nuclear, right? But health physics can do a lot of things that nuclear engineers can do. Nuclear engineers can do a lot of things that health physicists can do as well. So the field is it's in the same school actually. My name is David. Thank you for joining. Even though this is a presentation for my professor, for her to look at. I'm making this video for the general audience. It will be on YouTube. So if you're joining me on YouTube, welcome. Hopefully this video will help you. If you're not part of my grading, the people who are grading me, hopefully this can get you into nuclear and get you interested in that field. Usually I have one or two people who are not per video that I would make of this, who are not in the field, that like, oh, they're like, oh cool, this is cool, I didn't know this. Okay, so we're going into SMR. What are SMRs? They're small modular reactors. And this is just like the growing market for small modular reactors. If you don't know, if you want to know more information about SMR, I make a full in-depth video with all the 6 types of SMR right now. This is 2025 going into 2026. So the technology is in that year. If you've joined me like 3-4 years after this, technology may have improved a little bit. So there might be more types, right? So this is at Oregon State University as well. So if you're looking to join to do something in this field, I'm doing it with Oregon State University. So yeah. So what is this presentation about? And my face on the top right there is cutting off some of the things. So this is more of the market, the growing market of small modular reactor, the SMR, and the new customers, what the customers would be, and the IAEA role in safe and secure deployment, right? So regulatory as well, because these are new technologies, so you need to have. So IAEA will talk about the role of governance of it later in this presentation, but we're going to start off with the market. We'll do a brief overview with what SMR is. But if you have not seen the first video, I would recommend it's the video right before this, right? So this is an independent study course for radiation health physics at OSU, of course. And disclaimer, all images here are generated by AI. I have prompted myself. I'm doing this experiment with the PowerPoint right now, so I just kind of want to try it out. We'll see how it kind of worked out and what you guys feel, what the professor feels about using AI to kind of generate image. So there's no plagiarism there. So there's no need to send links on whatever. I'm not stealing any type of intellectual property from doing this. But I just wanted to try out the AI setting. There's this new AI thing with the Google Slides, and this is where I built my presentation off, is from Google Slides. So I was just been prompting it to how to create the image, and then I could insert it. So I created all these slides myself, by the way, though. I did create all these slides. There's a little button to clean up the slides, so I just kind of push it, and they just clean up the whole slides for me. But everything is in my Word. Yeah, they just clean it up a little bit. So I might make some commentary on that as we go on how the AI is, because this is very interesting as well, as much as the SMR. And I'm making, like I said, this video is fun, right? It's fun. It's only 2-credit course. So I'm just trying to have fun with the audience here, with the YouTube audience as well. And usually I have like 1 or 2 people he's not in this field per video that we come in and comment like, oh yeah, that's very interesting. So it's for them as well, right? So so we'll start with the introduction, SMR and their market emergence, right? So So the purpose of SMR is nuclear power, right? But nuclear powers are big, especially the traditional one. They require this huge cooling tower. They take up like a lot of room and land, and but they can generate a lot of energy, right? But it costs a lot of people because of like China syndrome, right? Like which is the movie that came out during the 3 Mile Island incident that caused mass panic with nuclear, like big nuclear like facilities, reactors with like this huge. It caused a lot of fear. So SMR is kind of the answer. SMR are advanced, or small modular reactor are advanced nuclear fusion reactors, right? That generate like less energy, but they're smaller. They're smaller. They're designed for modular factory-built construction. So usually they are built in a factory, like pre-built, and then you kind of finish building it at the site. But the bulk of the building, it can be shipped over like a truck and multiple Lego pieces, and you can and they're a lot smaller, right? They don't generate as much power, but they're more portable, right? So we talked about what their uses are and why you would prefer that over in the last video. So like I said, I don't want to keep beating the dead horse, but please watch that video if you have not already. This is just kind of building on the knowledge from that video, right? So the purpose of this is also to provide low carbon, reliable energy for both grid and off-grid location, right? So like we're in a age where there's global warmings, among other things, pollutions, and whatnot. So like we're looking for green solutions, and nuclear is definitely the path, right? Like if you're like, oh, why not solar? Why not wind? Well, solar is not reliable. It is dark most of the time, right? Right now when I'm making this video, it is the middle of the night, and you're not generating power. Wind is not always blowing, and so nuclear is actually something that's sustainable. You will always generate energy as long as there's nuclear fuel, which is very easy to make in this little nuclear pellet. But last video, right? Like I said, around 70 SMR design are under active deployment across more than 20 countries as the current, right? Technology is still pretty young, but we're really looking into it. Around global momentum surge around 2023, right? Where a country pledged to triple nuclear power by 2050, right? Nuclear is very clean, very safe now, right? And the modular reactors are actually safer than the traditional bigger reactor because they're smaller. And of course, like I did talk about it, a lot of the newer reactors don't use boiling water as much because if you have water, it can create a lot of hydrogen and hydrogen explosion, which is what usually cause these type of nuclear incidents that we have around the world, like Fukushima or Chernobyl, which I did talk about it in detail in a few videos ago. So please do reference old videos, right? SMR aligns with net zero carbon transition and energy security goal, right? So nuclear is the future for sure, right? Of course, right? Why SMR market is growing? So and like I said, this is going to be more of a market and regulatory video. It's not more the scientific video is last video and a few videos ago, right? So but let's go into the market. So because of the climate change community, right? Like the green community. I mean, so like climate change, nuclear energy is recognized as an essential. It's net zero, right? Under the Paris Agreement. Energy security and decarbonization. So like I said, decarbonization, you want to get away from fossil fuel, which is very reliable, right? But you're eventually going to run out of fossil fuel, and the problem with fossil fuel is it does emit a lot of harmful chemicals into the atmosphere because you're releasing hydrocarbon into the atmosphere, among others, right? SMR provides stable power for a alongside renewable. If you want to debate that, I think if you just have SMR and you just get rid of renewable entirely, because renewable are not very very they're not reliable. So you can't throttle energy and lower energy like that. So even though like, oh well, like, well, we can have energy in the daytime, you could give these nuclear power a break. That's kind of not how it works, right? Like nuclear grid or power grid in general has to be stable throughout. You can't have period of cloudy and then period of darkness and period of wind and no wind, right? So that's that. Like, just go to it. So this is just something I want to point out, because I use AI to kind of clean up my PowerPoint and just add something into it. So it added the renewable into the slide. But when I did create the first slide, it didn't have that. But it did put in like the fun little where my mouse is, this little bullet point, which is really cool. Really cool that they draw it. And and the graph also, I prompted. I was like, hey, this is what visual, right? Like the visual. This is what I type in on the bottom, right? Visual projectile SMR capturing significant share, blah blah blah, and this is the graph, the table that I generated. So AI is getting very advanced. It's kind of scary how advanced they're getting. They're gonna come for our jobs in the future, for sure, right? So let's move on into the next slide. But it's fun. It's fun. I'm trying out a new thing, and we'll see. I'm also a college professor as well. I teach math, lower math at a community college. But it is a fun debate to have about AI and how students should use AIs, right? So let's go over to global market outlook, right? So AI IAEA data, can't talk, right? From 2024, all resources and all reference are at the last slide. So I'm gonna hover over the last slide at the end of the presentation a little bit if you're interested in fact checking or going through these resources. So all resources are in the last slide. Okay. So there's over 20 countries pursuing national. Let's start with nuclear capacity could be 2.0 greater by 2050, with 20%, 25% from SMR or even greater, right? It does take time to build and deploy, and all the rules and regulation when it comes to nuclear. There's a lot of regulations right now that's really hinders the building of it, because when you talk about nuclear, people get really scared. A lot of panics, right? So there's a lot of safety things that need to be put into account to make the public at ease, right? So over 20 countries pursuing SMR right now. So us, right? And why do we need the greater the greater energy, right? Because of AI, right? Because the president has talked about, like the current administration, right? Talk a lot about AI, and that we need to keep. And why is AI important when it comes to energy? Because AI takes a lot of energy to calculate, to do a lot of its tasks. So it requires a lot more energy. Fossil fuel, renewable is not going to be enough for it, right? China, Russia, Canada, UK, France, Japan, huge nuclear. They use nuclear for their power grid, hence Fukushima, right? And then Korea. I was in Korea for a little bit when I was in the military, and of course they also use nuclear as well. China is a huge competition to the U.S., so we're not trying to lose to them when it comes to SMRs, right? Because SMR has a lot of application, not just civilian, also military as well. Like creating like bases or something. I did talk about it in the last video, where it can power like a grid off the grid, so it's harder to attack it. You can have maybe multiple modular reactors where one get hit, you have another backup, right? Versus a stationary power grid where it's more vulnerable, so to strikes, right? So once the power goes out, a lot of operation goes to a halt, especially in the Air Force or Space Force, where you have a lot of you need to have a lot of logistics, so you require a lot of power on the back end. Like emerging nuclear countries, so like you have Ghana, you have these like Saudi Arabia, Kenya, so you have Indonesia, you have like kind of like more close to third world, where these are actually clean energies for them to use, that produce a lot less pollution, and it provide them with sustainable energy, right? So they don't need to rely on fossil fuel from other countries and whatnot, right? So market trends right now shift towards smaller, flexible plants that fits regional and industrial energy needs. Um, Integration as SMR with renewable hydrogen production and uh, distillation provide sector engagement. So like I said, Google, Amazon, whatever. So like you might have private market that wants to get in cahoots and get on the SMR wagon, because all these tech industry, they require a lot of power for their own place. So they could just build their own SMR instead of having to rely it off the grid. It will be lower cost for them, and it won't put as much strain on the grid for the civilian use, right? So once, if let's say they overload the system, it doesn't go through the civilians as well. So SMR is it kind of shift people to more independence, right? Of this sector to go into more independent, so they don't need to rely on like the overlord, right? To have a monopoly on the energy, right? All of course, the map right there with SMR, I did prompt it. I did tell them kind of how to highlight, and they generate that map from AI. Isn't that cool? That's amazing, right? So, but I did prompt everything, right? And they generate that by themselves. Yeah, so that's pretty cool, right? Key industrial player and technologies, right? So table on the right is also generated by AI. I told them, I gave them the table, like what to put in each table. It added a few things to the table, which is kind of very interesting, right? So I did add the design, and I did kind of put in the size and the coolant, but then they kind of put in the application the status by themselves, right? So I don't know if these AIs are looking on the web to see those type of information, because I didn't give it that information. So that's pretty cool. So leading developers right now is the United States, and there's Westinghouse is the very very big one, TerraPower, nuke scale, right? So but Europe also have like Rolls Royce, right, which doesn't just make cars, right? And then you have China, which is a CNNC, which is a very big competitor, right? Korea also have their own, Japan. So these are the lead developers when it comes to modular reactors right now, SMRs, small modular reactors. So technological focus right now is water cooled, right? PWR and BWR. I talked a lot about these in the last video. They are existent. They use water to boil and then turn the turbine. They use water to cool it. But with water cooled, there are some dangers there with hydrogen, but it's legacy technology, which means that you don't need to reinvent the wheel as much, right? But you have like other type of design, which is more like molten salt. There's certain, and I did talk about this quite a bit. So reference to the past video, right, where the molten salt has a lot of corrosion properties to it. And there's different type, fast neutrons and whatnot, and microreactors. Microreactors are tiny. They generate a lot less, but they're very small. Modular reactors, where it's really good for mining defense, like really portable. You can pick it up and go. You can just plop it down and generate nuclear power anywhere you want. Very portable, very practical for a lot of like individual use. So the market for that will be very big. I can assume so, but they tend to be a little bit more expensive, per energy wise. Right. Who are the new consumers, right? So there's so many right now, because SMR is not like your regular nuclear power plant, where it's gigantic, that require a lot of money to maintain a lot of things. These SMRs doesn't require that many people to maintain it. Industrial customers, of course, like you have factories like steel, chemical. They require a lot of energy, so they might want to have their own little reactors with that they may create a building for it for themselves, or they might have micro reactors for that plant, right? Data center technology companies, definitely require a lot of energy, especially when it comes to AI, and like having their own might cut costs for the long term as well, because they don't need to pay other people for energy. They can just have it on site, right? developing nations, so like countries, third world, whatnot, SMR may be more practical, where you have these Lego bricks that you can just pop down to a place that really require that type of that type of energy, reliable energy that doesn't need to require like years of building. They just plop it down, put it together in like a few days, and then there you have clean nuclear energy, right? Of course, like Haiti, like as well, if they're like natural disaster, you can just plop in an SMR as well, pretty quickly. As also remote and military application, right? So like you have like your military bases, is of course deployment forward bases. You can just plop it in. Having a modular micro reactor, you spread them out throughout the base, so it's harder for the enemy to hit one of them, right, and then just shut down the entire base. Electricity wise, you can have it scatter all out, so you can't just hit a target, you know. So that's very technical, military advantageous in that sense as well. Utility companies and coal plant conversion as well. So you can use these modular reactor to convert old plants to make it nuclear. So a lot of like infrastructure for coal plants and all these type of plants, they already have the infrastructure for the grid and everything there. All you need to just do is plug in the SMR and plug it in, and that's pretty much all you have to do to kind of convert them. They're very easy. They're very easy. So there's all these type of customers would be very interested in. These are just to name a few. There's probably a lot more as well. Yeah. So hopefully you like the image there. That's really good. Yeah. I have to put props to the AI, because if I were to go look for the pictures myself, it's not going to be this good. Yeah, it's fun. It's a fun video. It's a 2-credit class. You know, it's just 2 credits. So I might as well have fun with it. So I experiment with AI a little bit. So I hope you're having fun as much as I'm having fun. You know, so the U.S. market landscape right now. So let's just look at the U.S. So you have like NukeScale. You have you have TerraPower. You have Westinghouse. You know, you have Vinci. You know, they're all making their own modular reactors, and you can read a little bit. Usually how I make my slides is I would kind of make notes, and then you can kind of read. I would like to talk through myself, and then like you guys, whatever's on the slide, you guys can read yourself as well. So market momentum right now, the DOE, which is the Department of Energy, they're really encouraging it, right? So there is a pathway to commercial liftoff right now. So with new technology, yeah, we'll see. And this administration really is pushing for nuclear as well. So there's a lot of interest in this type of SMR, you know, and it's great because if a lot of places can convert to, excuse me, I have a phone call. A lot of places can convert to SMR, you know, from power plant, fossil fuel, or renewable. More job for people like me, health physicists who need to go and inspect it, or nuclear engineers who has to go and create and invent new nuclear. So hopefully this nuclear market being boom is good for me, good for people in this field, right? So IAEA role, so we finally go to regulatory, right? IAEA role in global SMR deployment. So of course, it's not going to be just IAEA, which is international. You're going to have the local government as well, like which is the NRC, then the EOE as well. That would have to with this country, but IAEA is for internationals. What would their role be in SMR developments, right? So technical support and guidelines. So IAEA have a lot of data on this type of things. People working for them has a lot of knowledge in it. So they provide platform technical safety and economic guidelines to member states, right? Database and knowledge sharing. So like I said, they already have a lot of knowledge when it comes to this. So they can kind of help with that development by sharing all of this information with their expertise. Harmonization and standardization, right? So there's no need to keep reinventing the wheel. They can standardize and harmonize the development to make things more streamlined, and it flows a little bit easier. and capacity building and safety assurance. So make sure that things are safe. IAEA, of course, is known for making sure that people are not doing things that are dangerous, right? So there's ways to detect if someone are using nuclear for nefarious means, and they're very good at detecting that, and they also do inspection for safety assurance for the public as well. So health physicists like me would go in their team. So maybe in the future I'll work for them. We'll see, right? And I hope you like the um the the, the little image that the AI created with me prompting it a little bit, but they have exceeded my expectation again. So challenges and opportunities, right? So just gotta love these bullet points, right? Like there's these image in front of these bullet points that I would never be able to create myself. But fuel supply, right? So they're limited supplies right now. A lot of fuels for certain type of fuel was created because of war, but now because of war is over, people are not using nuclear. A lot of plutonium is kind of depleted, so for these like type of nuclear batteries, like kind of in one of the rovers. Of course, the uranium 235 has to be mined at Forge, so there are some challenges when it comes to that, especially when SMR becomes mainstream and everyone will need a lot more uranium, right? Economic viability, need for serial production to lower costs, as SMR are extremely expensive right now because the technology is very, very early stages of its development. So probably in the future, the prices will come down, just like everything with technology. So like for example, drone used to be so expensive, now it's so cheap. You can get one off of Temu for like $15. Right? So I'm not saying you're gonna get SMR from Temu, but yeah, as technology progresses, we'll see if we can create make cheaper type energy, right? More licensing complexity. So US 10 USC 50 is licensing. If you want to go do some law, so 10 USC 50. There's a lot of things that need to be revised for SMR, particularly because SMR and regular nuclear power plant are not the same type of like concern as all at all. So a lot of revisioning to those type of licensing needs to be taken into account what SMR is, and public perception. So elephant in the room is public fear, right? So I did make a video on public fear a few videos ago, not last video, but a few videos ago. You can reference that a little bit, but like people are afraid when you talk about nuclear radiation or anything like that. They get so afraid of that word, of that term nuclear. So we need to have to teach the public on what not on like the true danger and to overcome those type of fear, right? But I did make a video on that in the past, so this is just kind of an overview. So what are opportunities, right? So net zero, so they're net zero, right? They're very, very green. They're very safe for the environment. It allows global cooperation when you're building SMR to kind of save this planet. You know, like you have a lot of cooperation between people, and they create more jobs for people in this type of field as well. And then next decade growth as well. So like it will grow. This market is forecast to grow by $100 billion in 2040s, by 2040s, right? So we reached the end. So let's go over the conclusion, and I hope you like this this image here. I did put in like a little quote that I put into the main slide, but then they put it into the picture right on the right. So that's really cool what they did. Right? So SMR are reshaping the global nuclear landscape with flexibility, safety, and scalability, right? A market growth is fueled by climate goals, right? SMRs are very green, industrial need, and private sector demand. IAEA play a private role in harmonizing, a pivotal role, pivotal role in standardizing and enabling safe, secure deployment, and SMR present a bridge between today's energy challenge and tomorrow sustainable carbon-free future. So hopefully you guys learn a lot from this presentation, and I'm going to leave you guys with a quote. SMR are not just small reactors, they are a big solution for a clean energy world. Right, so hopefully you like that, my little quote. Let's go to references. All the references are here. If you would like to go in and read any of these papers or regulatory, there's a lot of things from IAEA on here as well. Thank you for joining me. Hopefully you love this video, you liked it. If you're not my professor, please, if you're just joining me on YouTube, thank you so much for watching this video. Hopefully you learned something new, and please like this video so other people can see this video as well. And if you are not already in nuclear field, this gets you kind of interested in that nuclear field. I would be really thankful if you have any questions on SMR or any type of resources, or like even this type of degree. If you want to go into nuclear and you don't know how to go into it, comment below and I can kind of help you guys into it. Like nuclear field is growing so fast right now, and we need as many people in nuclear field. I think like the demand for is outpacing the supply of people coming out from graduate, because nuclear, a lot of people are not very interested. It's very hard. A lot of people, when you say nuclear, they get scared, right? So, but we definitely need a lot more people. So, hopefully this video will kind of help people go into it. Please stay tuned. So this is the end of this presentation. Thank you so much for subscribe, by the way, so for future video, because I'll probably be posting more nuclear video future, but I'm gonna probably be making a video on watches next. So I know this has nothing to do with the project, so the project's over, professor is done. So anything after this is just for the YouTube audience. I'm gonna be making video on this Rolex Pagani design. It's like the Rolex. This is not a Rolex. It's a homage to a Rolex. If you know anything about watches, this is like this Rolex Starbucks, right? It's Submariner, and this is a cheaper version of it, but it runs just as well. Instead of paying $15,000, is $100. So I'm gonna do a review on that. So stay tuned for that video coming out. All right, guys. Thank you, and have a good one. If you have any questions, like I said, comment below, please. Please, and even if you don't have a question, you find this video engaging or whatever, comment below, subscribe, and like. Please share this video as well. Bye.